Hello, peoples of the internet. My name is William, and some people call me the Math Hatter. And today we are going to follow up on what I left hanging in the last episode on this. So last time we talked about systems of linear equations. So you have the linear equation, say y equals x plus 1, and you have another that makes a system of linear equations. And we went over a couple of them, and the top two left us in a very interesting place. This one up here led to a false statement, and this one down here led to a true statement, but nothing else. So we're going to figure out why that is the case with a bit of help of graphing. Give me a moment. So the last equation, the first equation that we looked at last time, the first set of equations was y equals x plus 1 and x plus y equals 7. Now, we know from graphing that we want this in the form y equals something with an x in it. So we subtract x from both sides and get y equals negative x plus 7. And now these are both in the form that we talked about last time, mx plus b. So this has a slope of 1 times x, plus 1. So this is the slope, and this is the intercept up here. So the first point that we have, where x is 0, y is 1, because we just add 1. Then we can plot the next point, and the next point, and so on. Now this, the slope is negative 1, so we actually go down 1 for every one that we go over, and the first intercept is here. So we go down 1 and over 1, and down 1 and over 1, and then down 1 and over 1. And these lines continue forever, but they intersect at this specific point, where x is 3, where we go 3 over and up 4. In other words, x, because this is the x-axis and this is the y, x is 3 and y is 4. And that's exactly what we saw when we solved this equation earlier in the previous episode. Now, another equation that we had, second one up, is going to need a bit of a redraw, so hold on. So the next set of equations that we looked at was 2y plus 4 is 0, and x is y plus 6. And when you try to solve it so that y is on one side, you get a very interesting result here. You don't get x in the answer at all. You just get y is equal to a number. And this is very simple. We can still write it as mx plus b, because we can just have m be 0. And 0 times any number that you usually encounter is still 0. So the x term actually disappears completely if we don't move up or down at all as we go along. So we just have y equals negative 2 from left to right like that. And this one is simple enough. We start at negative 6 and we go up 1 every time we go over. And we again get the point that we were looking at last time for negative 2. And on to the next one, which is where we encounter something very, very interesting. So the third set of equations that we looked at last time was y equals 2x plus 5 and 2y minus 4x equals 10. Now we can rearrange to get y on one side, and that is we add 4x to both sides. So this is now 10 plus 4x. We can swap that around. We divide by 2, and we get y equals 2x plus 5, which is the exact same equation as this. So the graph of it looks like we start at this point, we go down to every one, we go over to the left, because when we go to the right, we go up 2, so if we go left, we go down 2. And it's a nice line like that. And I can't draw this supposed second equation because they are in fact the same. Any point on this line will solve both of these equations because both of these equations lead to the same line. Now, when we changed it last time, we will get something different as our equation. And this equation is why, there can never be a solution to both. Because we see if we start up here, we go down 2 for every one, we go to the left, down 2, down 2, down 2. These lines are perfectly parallel. There are no points that are on both lines at the same time. Never will be, no matter how far you go out, because they're constantly one apart from each other. Because for every one we go over, we go up 2, and to the right 1. So this separation distance stays the same no matter how high up we go. And that is why this system of equation doesn't work, and why the just previous one works too well, you could say. So, if you want to know whether a system of equations will have 0 answers, or all answers, an infinite amount of answers, you could put in any number and you would get out a working answer. Or if it just has 1, you can change it around to this form of equation, and you'll have 2 of those, so we'll call this nx plus q, I guess. And if m and n are not equal, then you'll have 1 solution. If m and n are equal, mb and q are equal, then you'll have all the solutions. But if m and n are equal and b and q are not, then you can't have any, because the lines will be parallel. There will be no points that can fit on both lines at the same time. I do hope you enjoyed. I do hope you learned. My name has been William. Some people call me the Math Hatter, and I will see you next time. Bye.